So anyone have issue to understand these all types of static route? Anyone have issue to understand these all types of static route? Standard static route, default static route, floating static route, host route, summary static route, recursive static route, directly connected static route with interface plus next hop, and null zero route.
Sir, this null route means a specific interface for a network address we are blocking, right?
Right,
A
yes.
specific
It is
subnet.
used
So
to
that
drop the traffic.
okay, that time what will the command, sir? IP route,
IP route, the network,
okay, which we want to block, right?
IPS, which you want to block. Let's say I want that router should drop the traffic for 10.1.1.0 network. So network ID, subnet mask, and then exit interface is going to be null 0.
Okay.
This will create, it will create backhole. Backhole on the router. Any other route? Summary route, guys. Summary route, host route, floating static route, default route. Any question in these types of route? Recursive static route, directly connected static route. Any issue to understand?
And host route means /32 will give.
Yeah.
Okay.
Configuring route for a specific IP address. Configuring route for a specific IP address. Floating route means configuring primary and secondary scenario.
Yes, with the AD value.
Yes, configure, you can say configuring backup path. Configuring backup path is called floating static route, right? Like I can say IP route 0.0.0, 0.0.0, and next of IP address 1.1.2, and then IP, here we can define AD value, let's say 5, and IP route 0.0.0, 0.0.0, 2.2.2.2, and AD value I can set 10 here. And instead of default route, you can configure any specific route as well, right? 10.1.1.0. Yes, guys. Anyone have any question in these types of route?
सर यहाँ पे हम लोग इंटरफेस मेंशन नहीं करेंगे
कहाँ पे?
यहाँ पे आईपी राउट
कर सकते हो,
0.0.
कर सकते हो ना, करना चाहिए आपको दोनों चीज मेंशन, आईपी भी एंड नेक्स्ट हॉप भी. Clear, guys? What is summary route? Summary route?
We have when we have n number of subnet in the same, so we
Yeah,
can.
used to reduce the size of routing table. Used to reduce the size of routing table. So for an example, if this is my scenario, if this is my scenario, and even I can delete the switch here, I can create the loopback directly. Let me delete the switch. And these are the loopback on router number 1. And here also I am deleting the switch. You can assume that these are the loopback on router number 4. And these are two ISPs. Router 2 and router 3 are two ISP. This is my, let's say, side 1 or head office. This is branch office somewhere else at different location. And both are connected through two different service provider. And you will be manipulating the path between the service provider, right? If you want to forward all traffic from side 1 to side 2 via router number 2, maybe you will configure the best default route, right? Or maybe a static route. What I am saying here, that this is a different side. Side 1 and this is side 2. And two ISP are there. Through a static route also you can manipulate the path, and in the dynamic routing protocol it is going to be much easier, but here also I can manipulate the path, right? I can say this is SP1, service provider 1, or ISP 1. Let me edit it, change the color to red, and increase the font size to 20, let's say. Not 20, 18 is, yeah. This is my ISP1 and this is ISP2. Right? So first of all, how I will configure the static routing? Let me access these routers, all the router, R1, R2, R3, R4. So IP interface brief. See, IP is already configured here. So IP interface brief exclude unassign. See, IP addresses are already configured. On fast Ethernet 0/0 IP address is 12.1 and fast Ethernet 1/0 IP address is 13.1, and after that these are my loopbacks here. So IP route, you can see in the routing table only directly connected networks are there. Right? Means we have not configured routing. On router number 2 also we can verify the IP. So IP interface brief exclude unassign. This is service provider router, and you can see IP configuration. Then on R3, so IP interface brief exclude unassign. Here also you can verify the IP. And on finally router number 4, last router, so IP interface brief exclude unassign. So see guys, IP address is already configured in this scenario. We need to configure routing only. Routing, we need to configure routing here. On router number 4, first of all, on the ISP should have route. Go to router number 2 and say IP route 10.1.0.0. I am configuring like this so that all my subnet will come. Even here we can configure summary route, summary static route. What will be the summary address of these 3 subnet, guys? Summary address? What is the change? 10.1.0.0/22, right? So I can configure this route here, 10.1.0.0, and what will be the subnet mask of /22?
250.
Yeah.
This will change, sir. This.
What will be the subnet mask? Hello.
252.
Yes. 240.
Some are saying 240, some are saying 252.
And 248.
What will be the subnet mask for /22?
250.
252.
Yes.
So 252. And then I can say exit interface F0/0 because this network TAN subnets are reachable from F0/0 only.
252.0.
Yeah, 0.0. And then next up IP address is going to be 12.1.1.1. What will be the summary address of this subnet on router number 4?
22.
192.168.0.0 and 255.255.252.0, and exit interface F1/0 and next up IP address 24.1.1.4. Clear, guys? I am expecting you all know this. You all already know this. Same like this, we need to configure route on R3 as well. IP route 10.1.0.0 255.255.252.0 exit interface F1/0 and next up IP 13.1.1.1, and then one more IP route 192.168.1. 1 dot, not 1, 0.0, 255.255.252.0, exit interface F0/0, and next hop IP 34.1.1.4. So on the service provider routers, we have configured the static route. We can verify it. So IP route static, right? Gateway of last resort is not set, right? Here we have not configured default route. These are the specific route, but not all the individual specific route. We have summarized that. This is summary static route. What we call it? Summary static route. Right? If you will open any route in detail like this, so IP route and 10.1.10.1.0.0. So you can see the detailed information. It is non-via. Static route distance value is 1, metric is 0, right? Next hop IP is 13.1 and exit interface is fast Ethernet 1/0. Even guys, you know, router is not forwarding traffic by checking their routing table. This process which we are learning now is called RIB, routing information base. You know, router store the routing table, RIB table, in their RAM. So this is part of CPU. When router is checking their routing table, that means router is utilizing their CPU. So that's why what will happen here, router will make one duplicate copy of this routing table in the FIB, in the TCAM. In the TCAM memory, it will store the duplicate entry. Like you can see in the routing table, many informations are there: distance value, metric, routing discover block, next hop, exit interface, metric, traffic share count. But if you will check the SAP table, so IP SAF and 10.1.0.0, so you can see how fair it is. It has just make the duplicate entry of this RIB table 10.1.0.0.0, and there is only 3 information: network, next hop, and exit interface. So router will use actually this table to forward the traffic. Router store, next hop, and exit interface. If you want to see the actual RIB forwarding, then you should disable SAF on the router by running command no IP SAF. If you will remove this command, then router will use routing table to forward the traffic. It will be using more CPU than, right? So that's why it is recommendation to enable the SAP. Even by default, SAP is enabled on many routers. Clear? Later
Yes.
we'll talk about SAP also. Not worry. Now on router number 4, I can configure default route towards service provider. IP route 0.0.0, 0.0.0, and I can say what? F0/0, and next hop IP address 24.1.1.2. Right? And I can configure one backup default route also on F1/0, and this time IP address is going to be 34.1.1.4, and AD value I am going to set here 10. Invalid next hop address. Next hop IP address is going to be 3.3. Right? So now you can see here on the routing table, so IP route. So IP route is static. There is only one default route. Towards which router? Towards ISP1, correct? There is one default route towards ISP1. But if you will check the running configuration, so run section IP route, there are 2 default route. There are 2 default route you can see. Right? One with metric 1 and one with metric 10. So this is called floating static route. On router number 1 also, I will configure one default route towards ISP1. Right? I am going to prefer ISP1 over here. So 0.0.0, 0.0.0, and F0/0, and next hop IP address 12.1.1.2. And I will add one backup route, IP route 0.0.0, 0.0.0, exit interface F1/0, and next hop IP address is 13.1.1.3. Right? Now can these 2 LAN communicate, guys? Can these 2 LAN 10 and 190, 10.1.1.0 and 192.168.1.0 communicate with each other or not?
I guess.
If I am going to
Yes,
ping,
it will
Yes,
come.
sir.
if I am going to ping 192.168.1.1, let me check the IP address on router. So IP interface brief exclude unassigned. Yeah, IP is 1.1. So go to router 1, say 1.1 and source 10.1.1.1. If I will not define the source, will ping work?
Yes, that I
Yes, it
agree.
will. Yes, it will work.
Ping is working because of default route. Because of default route, ping is working. Otherwise, router 4 will not have 12 subnet. Source is going to be what here? 12. Okay. Now, if I will define source here 10.1.1.1, then also you can see ping is working. And if I want to find the path, like trace the ISP, that via which ISP it is forwarding the traffic, I can use traceroute command. Traceroute 192.168.1.1 and source 10.1.1.1. Then I can say numeric. So traffic is going to 12.2, miss router 2. After that 13.3. It is forwarding traffic to 13.3 also. So IP route. Okay, so here it is performing as load balancing. You can see router 1 is performing load balancing. Router 1 is performing load balancing, right? So if I don't want to achieve load balancing here for now, do so run section IP route. For now, I don't want to perform load balancing. Let me remove this route, say no to this, and let me add it again with higher AD value. With AD value, let's say 10 here, right? And now so IP route static. Now you can see only one default route is there, and now if you will trace route, then you will see traffic is going via router number 2, 12.2 and then 24.4 router 4 IP address. My traffic is going via router 2. Even on router number 2, you can debug IP packet. Debug IP packet. And after that, if I am going to ping, if you don't want to use trace route, then also no worry, right? Sorry, not on router number 2, on router number 4. Here also on router number 2, you can see it is forwarding IP packet from source. This is multicast message. This is not the message which we are talking about. Source 12.1. So IP protocol summary. RIP routing protocol is running. So IP protocol. So see guys, RIP routing protocol is running. Let me remove the RIP. No router RIP. No router RIP on router number 3. So IP protocol summary. So IP protocol summary. Here RIP is not running, only a static route, connected route are there. You can see on router number 4. So IP protocol summary. Here also a static route, connected route are there, and on router number 1. So IP protocol summary. Oh, fine. Only a static and connected routes are there, right? So on router number 2, on router number 4, on router number 2, I am going to disable the debugging and go to router number 4 and say debug IP packet, right? Like on router number 4, I can identify that router 4 is receiving traffic on which interface. Now if I am going to ping the same IP address, then router 4 will show you all the IP packet. You can see it is receiving on which interface, on fast Ethernet 0/0, and fast Ethernet 0/0 is connected to which router? R2, right? So traffic is coming from R2, and on router number 1 we can see the reply message, right? From router number 4 also we can trace route, or here I can enable the debugging. Clear? This is so simple scenario, right? Now see, so IP route include 0.0.0. Guys, gateway of last resort is 12.1.1.2. What will happen when this link between router 1 and router 2 will go down? If let's say ISP1 will goes down, if ISP1 will goes down, interface F0/0, if I am going to say shutdown, what will happen? The line protocol of this interface will goes down, and once line protocol of this interface will goes down, it will install the backup default route in routing table. So IP route include 0.0.0. Now you can see gateway of last resort is 13.3. Default route is reachable via R3. Now can I ping 192? Will ping work now? Will this ping work, guys?
Yes, sir.
Not working.
Yes.
Now tell me why ping is not working. No, ping is not working. See here. The link between R1 and R2 is down. Router 1 have shifted the traffic towards router number 3, but still ping is not working. What is the issue? Just check the packet flow. See guys, on router number 4, I am going to enable debugging for ICMP. Debug on all. Debug IP ICMP and go to router 1 and ping again. Right? See, router 4 is generating reply message, echo reply. Yes or no? Source IP 192.168.1.1, their IP address and destination IP 10.1.1.1. Router will compare this destination with routing table. So IP route 10.1.1.1. Is route available in the routing table?
No, because
No.
earlier it was.
If default route is a specific route is not available, then router will check what? Gateway of last resort. So IP route include 0.0.0.0. So yes. So yes, default route is there towards router 4, 24.1.1.2. So router 4 will forward the traffic reply message to whom? To R2. And R2 don't have path to reach R1 now. Yes or no? That's why ping is not working. It is using what? Asymmetric routing. Router 1 is forwarding traffic towards ISP2, but router 4 is forwarding reply towards ISP1, and the link between ISP1 and R1 is down now.
Yes.
Again, when the link will come up, when
Sir, but there was a floating route, no?
This is floating route, na?
But it should work.
It is working. It is
But it
working,
is
brother. It have changed. It has changed the gateway of last resort. Earlier it was 12.2. Now it is 13.3.
Yes.
But how your
Achha, we
router
have to
4
configure again at R4 also floating route.
on router 4 also it is running, but router 4 is not going to shift the default route because their link is up. Their link is up. Now again, when on router number 1, interface F0/0 will come up, what will happen? Once line protocol of this interface will come up, router will install the primary default route. You can see so IP route, primary default route, and now again ping will start working. You can see now ping is again working.
But this is a problem, sir. If link on down, so R4, how it will get to know?
How it will ping, like data forwarding
So how it will
issue.
change the traffic mix towards the R3 again?
Routing dot is working fine. Now see, earlier what was the issue? When the link between ISP1 and router 1 goes down, router 1 have shifted the default route towards R3. It have installed the backup default route.
Yes.
Now router
Correct.
1 will route all the traffic towards R3. R3 will
Yes, sir.
route that towards router 4, and router 4 will route the traffic towards router 2. And this link is not working. So that's why ping was not working. So if I want that if this link goes down, then router 4 should also use this default route.
Correct.
What I want, when this link between ISP 1 and router 1 will goes down, then router 4 should also shift the path. So what we can do now, we can use the track route, right? There is one default route towards router 2. In the routing table of R4, I can add track feature with that default route. I can add track feature simply on router number 4. I can create one track. See, on R4 what I can do, I can create one track. Let's say track object number is 10, and after that it is asking you, do you want to track the interface? No, I don't want to track my interface. Do you want to track list, means group of object, stub object, and the IP option is there. For now you can use IP here. IP SLA is one feature for generating automatically ICMP packet, dynamically ICMP packet. SLA, service level agreement, it is used to track the IP address. IP SLA is used to track the IP address. Any service, like if I will say IP SLA and keep pinging R1, let's say 12.1.1.1.1. So until and unless it will be receiving the reply from 12.1, your SLA is going to be up. Once it will not receive reply from 12.1, your SLA will goes down. Once your SLA will goes down, your track will goes down. And once your track will goes down, router 4 will change the default route.
So one question.
Yeah.
Uh, if there is any packet drops or latency, also the IP SLA will work, no?
IP SLA means latency
No,
mean?
if there is any packet drops on the link or latency on the link, we can define SLA and we can call in track, no?
Yes, you can.
Okay.
Through SLA, you cannot measure the quality of link, like the delay, reliability,
That's what.
slowness. You cannot measure those things.
Okay. Sometimes sometimes ticket comes like SLA flapped.
Mhm.
So what it can be like?
You will understand that. See
Sir,
now
it
first the basic tracking. IP
Okay.
SLA, and
sir,
now I can call to a SLA number. Yes. Yes, brother.
sir, suppose R1 to R2, this link will come up after 5 minutes. Then this track will be the change our track or not?
Yeah. Again your track will come up, like first IP SLA will come up, then your track will come up and it will revert the default route again. Yes.
Okay.
So I said track 10, and in the track 10 I called IP SLA number 10. Here I am not defining anything, delay, those things, leaving everything on default. Now let me create IP SLA 10. IP SLA number 10, and here if you will put question mark, see there is one option to send ICMP message, ICMP echo message. So I am saying ICMP echo message to whom? To 12.1.1.1, let's say. To whom? To 12.1.1.1. From which source interface? From source interface fast ethernet 0/0, like this. Getting my point? So what will happen now on router number 4? Router 4 will be keep pinging 12.1.1.1 from this source, and until and unless reachability will be there, your IP SLA is going to be up. And here you can configure the threshold, timeout, and the frequency. You can manage your IP SLA. Let's say I am going to say
Sir, it is like HSRP inbuilt tracking like this.
this is not like that.
Okay.
SLA number 10 and result 10, sorry yaar, IP SLA 10, threshold 10 and timeout I can set 10 over here, and timeout result you can set the frequency also, like how frequently it should send the ICMP packet. Let's say after every 2 seconds. This is in second. So after every 2 seconds, or if I will set 1 second, means after every 1 second it will be start forwarding traffic, ICMP traffic. Let me check, is router 4 generating any ICMP traffic for 12.1.1.1? And we can do one more thing here. Now I can add one static route for 12.1.1.1. 255.255.255.255. What is this, guys? This is host route, host static route. Am I right? 24.1.1.2. This is host static route. And now debug IP ICMP. You can see router 4 is not generating any ICMP message now, because we have created the SLA, but we have not start the SLA. We have not scheduled the SLA. So let me schedule it. Say IP SLA number 10, or schedule, and then number 10, and then it is asking for live. I am saying, let's say Failover. For Failover I want to track 12.1.1.1, and then it is asking for a starting time. When you want to start? I want to start right now. So now, right, like this you can schedule your SLA, and you can see it has started sending ICMP packet to 12.1.1.1, and it is getting reply message. So as it is getting reply message, my SLA is going to be up. So IP SLA number 10, sorry, on all. So IP SLA and summary. Here is the summary information. You can see in the SLA you are pinging, sending ICMP echo request message to 12.1.1.1, and not summary, SLA group history code statistics. Failover, you can verify the configuration. These are the verification command, nothing else. Somewhere we can check the track status. So IP SLA, so IP SLA
सर बस शो ट्रैक कर दो.
सो ट्रैक तो दिख ही रहा होगा, ट्रैक तो आप ही होगा. सो ट्रैक इज showing down. Track is down. Ping 12.1.1.1 source F0/0.
सर पोर्ट शटडाउन में है ना शायद.
कौन सा पोर्ट?
R1 पे कुछ तो पोर्ट शटडाउन किया था ना हमने.
नहीं, रिचीबल है. 12.1 को पिंग जा रहा है. सो IP SLA So IP SLA, just give me 1 minute, let me check the command. What was the command? Ethernet monitor. No.
सर शो रनिंग कॉन्फिग पाइप इनटू ट्रैक.
नहीं, उसमें SLA का स्टेटस नहीं दिखेगा ना. SLA का स्टेटस एक कमांड रहता है चेक करने का. IP SLA, IPLS history, IP SLA scheduling group
show I
ट्रैक क्यों डाउन है फिर? सो ट्रैक
हाँ,
sudo track list debug IP ICMP. Yeah, ICMP reply message is coming. Just give me a minute. So IP SLA
so show IP SLA statistics और उसके बाद वो 10 डाल दीजिए.
statistics number 10. यहाँ पे स्टेटस नहीं दिखा रहा है ना यहाँ पे. Latest code operation timeout. Okay, so here IP SLA number 10. Entry already there, you cannot modify it. Fine. No track number 10 IP SLA 10 no. Clear IP SLA no. IP SLA number 10 IP SLA with IP SLA number 10 ICMP echo reachability echo 8.12.1.1.1 and source interface F0/0.
सर हम लोग 24 को भी ट्रैक कर सकते हैं ना R4 से, मतलब
हाँ क्यों
ये
नहीं, किसी को भी कर सकते हो. ट्रैक काम क्यों नहीं कर रहा है लेकिन IP SLA schedule number 10 start time now and live forever. IP SLA ये कमांड तो कुछ मिस हो रहा है. I'm missing one command. IP SLA no. Debug IP ICMP on all config T track number
सर
10
वो रीचेबिलिटी का कमांड रह रहा है क्या?
हाँ
ट्रैक track 10 IP SLA 10 reachability.
reachability. ठीक है. So track is up. Now guys, I will use this track with my primary default route. Do so run section IP route. My primary default route is this one. I'm going to remove it. I will say no to this, and after that again I am going to configure this, and this time I will add which track? Track number 10. So now router will install this route. So IP route and static. Router will be using this default route until and unless your track is up. So IP route 0.0.0, 0.0.0 default route. Here we are not able to find the track configuration. But so run section IP route. Here you can see in the routing table two default route are there. One is this one, which is the primary, but one track is running for this primary default route. And if this track will goes down, then router will remove this default route from their routing table. And once router will remove this route from the routing table, this route will become best. This default route will become best. Now I am going to again down F0/0 of R1 interface. F0/0 says shutdown, and go to router number 4. Now you can see your track goes down. Track goes down and on track will goes down. So IP route static. You can see default route is shifted towards router 3 now. Getting my point? Now next hop IP address is 34.3. Gateway of last resort is 30.3. Because track goes down, right? So this time ping will work. If I'm going to ping, you can see ping is working. If the link between IS router 1 and router 2 will goes down, both the router 1 and router 4 will shift the traffic towards ISP2 automatically. Am I right? And again when the link will come up, interface F0/0, I'm saying no shut. Again when link will come up, my track will come up. Right? Soon my track will come up. So track. Now track is still down. Now you can see track is up. Once your track will come up, so IP route static. You can see again default route is pointed towards router number 2. And again both the subnet can communicate. So
So
dynamic
there is no
failover
need
is
of a preempt, no?
what?
Like in last switching,
No,
actually in
that is
HS.
different thing, brother. No.
Okay.
Here
Okay.
it is. This is dynamic failover here. But guys, see, this is for one path. This is for one link. Can I configure so many tracks for all the links? No, it is going to be difficult. Right? Changing default route automatically in case of a static routing is very difficult. Lots of tracking should be configured here. And see, tracking is using CPU. It is forwarding one ICMP message after every 1 second. Lots of CPU. So whenever you have failover scenario, you will configure what? Dynamic routing. What is the limitation of a static routing? Limitation of a static routing is it is not shifting the traffic dynamically. If this link will goes down, if track is configured, then fine. Otherwise, manually you have to change the default route towards router number 3. And for all the link, we cannot configure the tracking. So many configurations are required, and even the performance will get reduced. But here, if you will configure the dynamic routing protocol, you will see your dynamic routing protocol will automatically choose this path as a best path. Automatically. So this is one limitation of a static route, that a static route can not perform failover dynamically. Right? Now I am going to remove the tracking from router number 4. Config T. First of all, let me say no to this default route, tracking default route, and after that I am going to add again the original default route. Say no track 10 and no IP SLA number 10 and number 20 also. Done. Now guys, between ISP1 and ISP2, now I want to achieve load balancing. We have seen the floating routing. Any question in floating routing? Clear?
No, sir. Clear.
Through tracking, you can configure the dynamic failover, but it is going to be complicated. In a static route, in dynamic routing, you will see it is so simple. So we have implemented host route, summary route, right? Null zero route. See, right now, if I am going to ping from router 1 to let's say 192.168.3.1 and source 10.1.1.1, ping is working. But let's say guys, in this subnet I have private subnet. In this subnet I have private subnet. I don't want that router should route the traffic for this subnet, right? Like other users, other side users are not allowed to enter in this network. So what I can do here on router number 4, IP route 192.168.1.3.0 255.255.255.0 and then null 0. I can configure one static route on null 0 interface. Now if I am going to ping this IP address, now see ping is working, still working because the IP address is connected to router itself. That is their local IP address. So that's why router is generating the reply message. Otherwise router will drop the traffic. For an example, right now I am pinging 192.168.1.3.1 via router number 2. If I will configure black hole on router number 2 for this subnet, config T and IP route 192.168.3.0 255.255.255.0 and say null 0. Now from R1, if I am going to ping, you can see ping is not working now. Getting my point? Now router 2 is dropping the traffic, right? Now router 2 is not generating any ICMP reply message. Debug IP ICMP and go to router 1 and ping again. See, it is only generating which message? Destination host unreachable message, just to inform the host. Right, this is one kind of message of ICMP. There are guys so many types of messages. You know only ICMP, echo request and reply, redirect message we have seen. Then the destination host unreachable message and so many other messages are also there. Right? Now between 10.1.1.0 and 192.168.1.0 I want to achieve load balancing. Right, so first of all I am going to remove default route. So run section IP route, like backup default route. I am going to remove backup default route. Do so run section IP route. I am going to remove the backup route. Where is backup route? Here it is. You can see this one. Right, say no to this and I will configure IP route 0.0.0 0.0.0 exit interface F1/0 and next hop IP address 34.1.1.3 with same AD value and same metric. This time I have two default route. So run section IP route. You can see two default routes are there with guys same AD value and same metric. That means this time router is going to install both in routing table. So IP route include 0.0.0. So you can see next hop is 34.1.1.3. only one default route is there. What happened? So run section IP route F0/0 24.1.1.2. So IP route Okay, you can see 2 next hop are there in the routing table. Now router 4 will perform what, guys? Now router 4 will perform load balancing, right? If I am going to debug IP ICMP, and if I am going to ping 10.1.1.1 and source 192.168.1.1, see, traffic is going from which interface? Is interface there? Interface is on all, sorry, debug IP packet. Here IP packet will work. And now let me send the ICMP traffic. See, traffic is going from which interface, guys? Fast Ethernet 1/0. It is performing per packet load balancing, I think, right? So if I am going to now ping another destination, let's say 10.2, then it should use F0/0 interface. Now you can see it is forwarding traffic from F0/0. Getting my point?
Yes, sir.
50% traffic via ISP1, 50% traffic via ISP2. It is performing
And
per destination load balancing. If you want to configure per packet load balancing here, you can change it. Go to interface, F interface range F0/0 and F1/0, and here I can say IP load sharing. Load sharing, I can say per packet. Now it will perform per packet load balancing, right? Means if I am going to send one ICMP packet, say repeat count 1, you can see first packet goes via F0/0. Now for the same destination, second packet will go from F1/0. Now you can see. Now my load balancing is per packet. Getting my
sir,
point?
load sharing means we are managing both links,
This
right?
is not load sharing. This is load balancing,
Okay.
right? There is some difference between load sharing and load balancing.
So
Load
load
balancing
sharing means
means
if we want to follow in one path, right? If we have higher links, so load sharing that time we will do
load
maximum
balancing
subnet.
means distributing traffic equally over multiple path. Distributing traffic equally over multiple path. 50% via ISP1, 50% via ISP2, like this. Load sharing means according to our requirement we will share the load. Maybe on this link I need to send critical traffic. On this link I need to send general traffic. That is going to be load sharing, right? Like on router number 1, I can have 1.192.168.1.0 is reachable via R2 and 2.0 is reachable via R3. In this submit we have critical user, so I have defined this path, specific path, like that. This is load sharing, right? So we can configure load balancing also. Similarly on router number 1 also we can configure load balancing. And on router number 1 I am going to show you the load balancing in case of RIB. This was load balancing of CEF, Cisco Express Forwarding. Now let me show you the load balancing of RIB, routing table, right? So I am going to say no IP CEF here to disable the CEF. Now if you will check CEF table, so IP CEF, it is going to say IPv4 CEF not running now. So now this router will use routing table to forward the traffic, and config t do so run section IP route. In the routing table you can see I have this backup route. Let me remove it, say no to this, and after that I'm going to remove the AD value. Now router 1 also have two default route, P route. Two default routes are there, you can see, and it will perform load balancing exactly like CEF. Debug IP packet, right, and ping 192.168.1.1 and source 10.1.1.1. Traffic is going from which interface? See, fast Ethernet 0/0 also and fast Ethernet 1/0 also. By default, load balancing algorithm in RIB is per packet, and by default load balancing in CEF is per destination. Okay, here also if you want you can change the load balancing. Then guys, anything else here in the static routing?
So how to change in RIB?
Huh?
Same, like same.
What? Yeah, same, exactly same command. In the SAP, even there are so many load balancing algorithm. In the global also you can run one command, IP SAF and load sharing. And if you will put question mark, it is asking algorithm. So algorithm, and after that if you will put question mark, you can see these all are load balancing algorithm only for SAF. But you don't need to learn it, right? The tunnel mode, universal mode, original mode. Even original mode is not in use nowadays, right? It was in use before universal mode. When Cisco come up with universal mode, then we are not using original mode. And the include port means for the load balancing it can use port number as well, right? So we can say include port number, then it will start using port number as well for load balancing. Actually, how SAF is performing load balancing? With the help of hash value. You don't need to learn the load balancing algorithm, but SAF uses hash to perform load balancing. Like let's say load balancing algorithm is per destination. So on the basis of destination IP address, it is going to calculate the hash value, and on the basis of that hash value, it will perform load balancing. Right? Then guys, IP route. Let me see now all the available option. IP route, and now if I am going to put question mark, it is asking for what? Destination network, destination prefix. Then one profile option is also there. What it's saying? Enable IP routing table profile, right? This is another feature we will not discuss now. Then we have a static option. We can choose the type of route, static, and after that we can choose the topology option over here also. Topology means configure a static route for a topology routing forwarding instance, and then VRF. These are the advanced technologies which we will discuss in upcoming days. For now here I am going to select, let's say, static. So now it is asking what? BFD protocol, right? Inter VRF, adjust time. So you don't need to select a static even. You need to directly define the destination network, let's say 10.1.1.0, and then subnet mask 255.255.255.0, and after that you can check all the rest informations. Like I can configure this route on any next hop IP address. I can also configure it on any interface, right? On the physical interface or on the virtual interface. It can be configured on virtual interface also. It can be configured on tunnel interface also, right? On all types of interfaces. Port channel also. Right? So if you want to define interface here, you can type interface, not interface like F0/0 like this. Interface type and interface ID. Then it is asking you the distance value or the next hop address if you want to modify. Let's say next hop IP address is 12.1.1.1. For an example, just I am taking anything. After that we can call to track here. We can add any tag value here, tag, and after that it is asking tag value. Let's say I'm going to add tag 10 here. Tag, let me tell you the benefit of tag. On router number 1, I am going to configure routes for side 2. This is guys side 1. Side 1 and side 2. In side 1, I am going to configure some static route for side 2. And in side 2, there are two types of traffic. Two types of, let's say, employees are there, like the sales teams are there and HR team is there. HR team is there. In the sales team, right now I have only one network, but let's say if 100 number of prefixes are there in the sales department and 100 number of prefixes are there in the HR department, then it will be difficult to understand the route belongs to which department. So that's why we have tag. Tag is nothing but the label. Like on router number 1, I'm configuring route like this: IP route and then 192.168.1.0 F0/0 next hop IP 12.1.1.2, and then I can say tag value 10, and I am adding one more static route for 192.168.2.0, and here I can set tag value what 20, and then do show IP route. Guys, in the routing table, are you able to see the tag value? Let's say static. In the routing table, global routing table, we are not able to see the tag. If I will open the network in detail, like so IP route and 192.168.1.0, here you are able to see the tag, right? Tag is 10. That means this subnet belongs to sales. We know that tag number for sales department is 10 and tag number for HR department is 20. So all the prefixes with tag 10 belongs to sales department, right? Now let's say I need to filter some prefix, sales prefix. So on the basis of this tag value, I can filter the route. I can say match tag value 10 and filter the route like that. Right? And before putting a static, if I am going to put question mark, again so many options are there. With the subnet, network ID or host name, you can search the route. Connected keyword you can use, DSCP, AGRP, these are the protocols. A static method I can use. I can check the summary information. Summary information means, see, summary like this. What it's saying? It is saying that how many connected subnets are there? 14. How many static subnets are there? Network, internal subnet, total subnet, like that, right? And there is one tag option as well, guys. IP route, so IP route and tag. And if I will put question mark, now it is asking tag number. If I am going to set 10, so it will show me what? The sales prefix. See now how easy it is to find the sales prefixes inside one. If you need to check the sales prefixes of side 2 inside one, you can use command like this. If I want to check HR prefixes, I can say tag number 20, right? It will open me the route. So here tag value is useful. Then apart from the tag, there was some more field. You can see like the track, you already seen the track option. Permanent route option is there. Specify the name of next hop and the multicast route, not for us, not for you now, and the AD value here is there. AD value we can manipulate. So these are the options available in the static route, in the configuration of a static route. Right? Now for the troubleshooting, see between 10.1 and 192.168.1.0 means between router 1 and router 2, or we can say between side 1 and side 2. I want to find the path. I can use trace route 192.168.1.1 and source 10.1.1.1 numeric. It will show me the path that traffic is going via on all. Traffic is going via router number 2. Right? And guys, via router number 2, let's say I want to check the MTU, maximum MTU. So I can use ping command then. Ping and then ping 192.168.1.1, and then it is asking, see, in the ping so many options are there, like I want to tell router that you are not allowed to fragment this packet, right? The DF bit is on. DF bit is on means don't fragment, means router are not allowed to divide large size of data into a smaller part of data, right? So if you will turn on this DF bit, router cannot perform segmentation, means segmentation feature is off on this data. And if I am going to not define size, let's say 2000 byte, and if I will ping you, hello, am I audible?
हाँ सर अभी आ रहा है
स्क्रीन दिख रहा है, नहीं दिख रहा है स्क्रीन?
Yes, sir. Screen visible.
Yeah.
दिख रहा है
So see,
Yes,
ping
sir.
is not
Recording.
working. That means the MTU between router 1 and router 2 is less than 2000 byte. The minimum MTU is less than 2000 byte, right? So I can increase some MTU over here, like I can say 1500 bytes. And now you can see ping is working because by default MTU is 1500 byte only, right? So in the production, after configuring routing, these are the technique to troubleshoot the issues, right? Then we can send so many traffic, like I can say repeat 100, send 100 ICMP packet to check is there any delay, packet loss. These are the troubleshooting of a static routing. You can see for 1000 packet, 100 packet, success rate is 100%, right? Even you can see the delay, minimum delay, average delay and maximum delay. Minimum delay is 28 seconds. This is the total delay, right? The request gone from router 1 to router 4 and the reply came from router 4 to router 1. The total delay, total time taken by R1, R2 and R4 to process the traffic. This is interface delay plus the processing delay, all types of delay, right? The average is 79 and the maximum delay is 144 millisecond, right? 144 millisecond, you know, is not good for the voice traffic. If you have this delay, then you will get packet loss in case of voice. So here you have to configure what then? Quality of service to reduce the delay for voice traffic only, because voice is delay sensitive traffic. So day by day we will be implementing everything here. And if you are configuring the lab, then try to use these types of command to verify the things. Trace route, ping, the extended ping. Extended ping is again very useful command for troubleshooting, like ping, then hit enter. It is asking for the protocol is IP. It is asking target IP address. I can define target IP address 192.168.1.1. It is asking repeat count, how many packet you want to send. Let's say I want to send only one packet, right? The what should be the size of data? Let's say size of data should be 1000 byte, right? Timeout, right? Now you can see I can troubleshoot the delay as well, right? We can check that within this specific timeout reply is coming or not. By default timeout is 2 seconds for ICMP. I'm leaving it on default. If you want to change, you can set like 1. Then extended command, yes, I want to use extended command. Let me see what are there. Now it is asking for the source interface. Source interface, let's say I am saying ping from loopback 1. Source interface is incorrect. Loop back 1. Now then it is asking for the type of service. It is related to quality of service. For now I am not using set DF bit. Do you want to set DF bit? Let's say yes. Validate reply data, no. Data pattern, no. Lose and ping it now. Now you can see if you are pinging through extended, then here is your delay and those all things, right? So according to our requirement, like for the application, actually in the industry you will have requirement. What will be happening, guys, in the industry? Like here we will have one application inside two, right? And the user employees inside one are accessing this application, and there will be some requirement of that application. The delay for that application is, let's say, 50 millisecond. Means within 50 millisecond, request and reply should be here on the PC. Then only this user can use this application, can work on this application. So this is not like adding route in the routing table is everything. This is just first step. This is just first step. But we are done with the static routing, right? We have covered everything, the advanced concept and the basic concept of static route, and now I am expecting you all are good familiar with the static routing. You know all types of static routing. Standard static route,
Sir, how
default.
to go this extended mode in ping?
Wait. Standard static route, default route, floating static route, host route, summary static route, recursive static route, directly connected static route with a interface, and next hop static route with null zero interface. So you need to keep in mind like this, that there are 9 types of static route, and I am okay with all types of routes, static route. And even you know the configuration of these all types of static route, and you have configured it in GNS3 or even G, and you have verified that all the devices are reachable. Then only you can understand dynamic routing. Because now first I need to tell you why dynamic routing, right? Means we'll talk about the disadvantage of static routing. One limitation I have already shown you. Dynamic routing. Today only I was planning to start dynamic routing, but now we don't have much time, so it's better to start tomorrow. What do you guys say?
Yes, sir.
Okay, sir. Let's start it from Monday.
Yeah, on the Monday we'll start the dynamic routing. But make sure till then you will configure these all things. If you are not going to practice, right, it will be again difficult for me to teach you the dynamic routing like static routing. In the dynamic routing, so many things are there, and we need to cover everything like this.
Yes, sir. There are a lot of things.
Yes.
Static routing. There will
Yes.
be routing.
Static routing is nothing in front of dynamic routing.
Yes, sir. It is excellent.
Guys, let's say I have a scenario like this. Two ISP are there. ISP1, like the scenario like yesterday. Two ISP1 and ISP2. ISP. But if both the ISPs are up, then we can utilize both ISP. So we should always configure load balancing here. But some company will be using active and like standby, or you can say primary and secondary configuration as well. Now on this router, this is F0/0 and this is F0/1, right? Let's say here I have configured one default route, that 0.0.0/0 is on F0/0 interface, correct? Means router 1 will be forwarding all the traffic towards ISP1. Am I right?
Yes, sir.
Now I want that whenever the line protocol of F0/0, line protocol of F0/0 goes down, then router should run one command. Which command? IP route 0.0.0/0 on F0/1. So that is also possible, right? Whenever router will get this log message, it will add this command. It will run the command automatically for you. And when again the line protocol of F0/0 will come up, again it can run command no IP route 0.0.0/0 F0/1. Getting my point? So these are very interesting things, right? Configuration on the router. If you will implement these all things, right, it is going to be interesting. You will have interest. Means we can tell to router to run any command according to the event. According to the event generated on router, means the log message, according to the syslog. Whenever any interface will goes down or come up, it will generate one event log, and on the basis of that log message we can run the command, right? That is also going to be dynamic behavior of router. This way also we can fail over the traffic between ISP1 and ISP2 automatically. But if there is some service on the internet, guys, let's say 8.8.8 is one service over here, and this is my primary ISP, and I am tracking this link. So if this service will goes down, then will router perform failover? Answer is no, because router will not get to know about 8.8.8. So in that case, again you will use tracking, track for 8.8.8.8. So until and unless 8.8.8 will be reachable, your track will up, and until and unless track will be up, it will be using this default route. Once 8.8.8 will goes down, or any service over here will goes down, your track will goes down. Once the track will goes down, router will remove this default route and it will install the backup default route. Even we can track both the ISP1 as well as ISP2. Multiple tracking can be configured. But what is the disadvantage of tracking? CPU, right? So this is not recommendation to configure so many tracking on the router, right? It can reduce the performance of your network. Okay, now can I close this lab?
Sir, by using firewall it can be done.
What?
Tracking.
What checking?
Tracking, sir. This type of tracking.
Checking?
What tracking.
Tracking, sir, track.
Tracking.
Tracking, yes, on any L3 device you can do it. Firewall is a device which works from L1 to L7. So firewall can behave like a router also. Firewall can behave like a switch also. Firewall can work at layer 4 also. On the firewall also we can tracking. Like on Palo Alto firewall, you might have seen port monitoring. So port monitoring is nothing but the tracking only in the Palo Alto firewall. Okay, yes, one guy was asking question regarding extended ping. Yes, now you
Yes,
can
sir.
ask.
Yes, sir. How to do that after? With how to go in that extended mode?
Ping. Type ping and hit
Okay.
enter.
Okay. And what was DF, sir? DF bit?
Don't
DF.
fragment.
Okay, don't.
ping a.a.8. And repeat. We can define the size, we can define the source, we can define the timeout, we can use toss field for QS quality of service, we can define the data, specific data pattern. Repeat means how many ICMP packet it should send. By default ICMP sends how many packets? 5. By default ICMP sends 5 packets. So IP route one dot 0 okay, and 1.1. Some more command are there on router, and this is question for you. First question, IP default network. What is the meaning of IP default network command? I will ask you the answer of this question in Monday class. What is the use of this command? Okay, here you can see I can define the network, default network, IP address of default network. So you need to find the meaning of this command. Default gateway, you already know this. IP SLA, you have already seen. Proxy ARP, and those all things we have already done. IP host. If I am saying IP host and routing, see, you can find the meaning of this command also. What is the meaning of IP host routing command? IP source route. IP source route. IP, then on interface, I think interface F0/0 IP IP subnet 0. What is the meaning of IP subnet 0? Anyone know the meaning of IP subnet 0 command? You need to find the answer of this meaning of these two commands. Okay sir, screenshot ले लीजिए. Take a screenshot of this. Any question? You can try static routing this way also, like see the first subnet of side 1 and the first subnet of side 2 should communicate via router 2, and the second subnet of side 1 and second subnet of side 2 should communicate via R3. This is called load
sharing.
So you can check the load sharing as well here. Otherwise, from the Monday we are starting dynamic routing. So once we start the dynamic routing, you will not have time to configure a static route. So make sure you will perform the lab before Monday. Now that's all for today.